Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about how to build efficient data lakes. Now, data lakes have been around for quite a while, and practically every organization is moving towards cloud and they are wanting to adopt big data technologies. They want to build data lakes. And the companies have progressed quite a lot in their big data journey, in their data lake journey. So today we are going to talk about how efficiently can we build data lakes, or what should we keep in mind whenever we want to build data lakes. So we would look at multiple things like governance, security, ingestion, all about data processing, storage, management, flexibility, scalability, cost, and data quality. We would talk about each of these and few things that an architect or a developer should keep in mind while building data lakes. So first of all, let's start with data governance, because data governance is an extremely critical aspect to think of when we are building data lakes. What is data governance? Data governance is very critical because it ensures that whatever data that we are bringing in is accurate, complete, and consistent. Because when we talk about data lake, it is like building a single repository or bringing in data from different places to one single storage. Bringing the data will be fruitful only when the data that we are bringing in is of high quality. And also we need to ensure that whoever is accessing our data lake has proper access, or they are authorized individuals. So one of the very important thing is to keep in mind about what is, so when we look at data governance, data quality, lineage, cataloging, as well as access, all of these are part of data governance. Data quality is utmost importance, so we'll talk about it separately as well, few slides down the line. But essentially, one of the most important thing is data quality. How good is the data that we are bringing in? The lineage. So we want to definitely track that if we are looking at certain attributes or some data, what is the lineage? From where is that data coming in? Because we may be bringing in data from multiple sources. The data traverses through multiple paths and transformation stages to get to an output stream or go to a report. So it is important to understand that lineage. Data cataloging is equally important because we need to catalog and understand what data are we storing in the data lake, because most of the time when people are creating data lake, they keep on bringing data, and if they don't do a proper data lineage or cataloging, the data lake becomes a data swamp which does not provide any value. So these three aspects come under data governance, and each of them have to be thought of very clearly. Access control. Now access control is important because when we bring in data, it is our responsibility to ensure who has access to the data and to what level. So we may have one table which has like 100 columns, but we may restrict the access of certain columns or some data to particular individual. Then there may be need of data masking, encryption. All of those need to be kept in mind. So that is data governance. Now we will talk a bit more in detail about data security. So one of the aspect of data governance is security, but essentially security means protecting sensitive data and ensuring that we are compliant. So every industry, whether it is insurance, it is banking, it is healthcare, they have certain standards to follow, and that is also dependent on the country. So Europe may have different standards, like there are GDPR laws. US may have different standards. So when we are building a data lake, we need to think about from where are we bringing the data, how are we actually storing it, who has access. And while doing that, there are multiple measures we can take, like one of them is encryption. Encryption at rest, encryption while data is in motion. What does that mean? So at rest means when we bring in the data and store it in a storage or file system, wherever, it has to be encrypted so that nobody can gain access, unauthorized access. Also, when we are doing processing, we are running queries, the data is traveling in the network because we are talking about distributed processing. While that transit, the data needs to be protected. So we use SSL and other mechanisms. Access control are like authentication, authorization. Somebody needs to log in. Either we use a key based authentication, we use username password based, or we use cert based authentication. So we can choose different mechanisms. And then comes the authorization. So even if I am authenticated using a cert or a key vault, I still have to ensure that even after authentication, what kind of access do they have? Do they have access, or are they authorized to get access to all the data or a part of data? So that needs to be clearly outlined. So a matrix needs to be built in terms of what are the authentication, who are the people who are authenticated, and what access do they have in particular over the data. Also, one of the important thing about security is doing auditing, because we need to know what all operations were performed by whom. Auditing sometimes is also considered as a part of data governance, because it is taking care of the overall governance of the data as to who is using it and how many times, at what time, all of that. It is very important, specifically when we have to comply with certain compliance for each of the industries. So all of this needs to be kept in mind. Data masking is also there. There is a need to mask data, which means if there is a column which stores, let's say, credit card numbers, it's a PII information. How do we mask that? What masking means is, we are encryption is different than masking. Encryption means we are encrypting the whole data, the value that is there, so that it is absolutely unreadable until and unless somebody has the key to decrypt it. But masking means, let's say it's a credit card number and last four digits can be made to XXX or something. So that's known as masking. All of these measures are used depending on what is needed. So it's very important. So there are probably, sometimes there are security architects who take care of this. Otherwise, big data architects also sit and discuss with business as to what should be the security mechanism. Okay, now when we spoke about the overall things like governance, security, but now we will talk about specific parts of our pipeline, or while building the data lake, the different things that we do. So the first step in a data lake is data ingestion. Data ingestion, what is it? It is nothing but the process of getting data into the data lake. Now, this looks like a simple thing where we are getting data from different sources, but it is the most critical thing, because it will ensure that how are we bringing the data? Are we setting up certain ingestion patterns or not? Because when we build a data lake, it is very important to identify what are the different source systems and establish ingestion patterns and standardization, because we don't want that whenever a new source comes, we start onboarding it without thinking what is the ingestion pattern. Then it becomes a bit chaotic if it is not thought through. So while doing ingestion, we think what are the different ways in which we can ingest data, like RDBMS, files, it can be streams, what it is. And then we define a pattern that, okay, if it is an RDBMS, how do I ingest data? If let's say it is some other data lake from where I am getting data into my data lake, I may not really copy the entire data. I can just create a reference to that table, which is in another data lake. So the pattern for me is to create an external table which is pointing to the table in the other data lake. That way I avoid copying huge amounts of data, a duplicate copy of that data into my data lake. So that's an ingestion pattern that I define for any uh, consumption that I'm making from another data lake. Then there can be another ingestion pattern which I define for files. If there are certain files which are coming and I'm picking them up, I may define an ingestion pattern saying that this is the location where all the files land. Would there be a folder created for each date? Would it be created by source system? How would the files land? How would I ingest it? So it is important to define those ingestion patterns. Then defining the frequency. Are they going to come ad hoc? Because when I design my pipelines, I need to know what is the frequency. Do they run every hour, every 6 hours, or every day? How will that be? Because if the data is not needed till the end of the month, do I really want to ingest data every day? Because it is going to consume some capacity out of my network. So those are the decisions that we take based on the frequency. Then there are sanity checks. It is important to do sanity checks on the data that is coming in. For example, if a file lands, is it duplicate? Is it a zero size file? These are some simple sanity checks. So what we should do is, while we are defining ingestion patterns, we decide what are the sanity checks we will do on the data and what is the action that we need to take. If the file does not come by a certain time, do I want to send notification, or I just don't run my pipeline because that file is mandatory? Do I stop my pipeline execution, or I'm okay, I go on but I send a notification? So these are few things that we decide. Are there sanity checks needed? Are there notifications needed? If the data doesn't come, is it a failure? What is the alternative action? All of this defines the ingestion patterns and standardizations for the data that is coming in. Every time I onboard a new source, I need to think about these. Then the next is data storage. Now I have ingested the data, but it will be stored somewhere in the raw format. And when I store the data, I actually have to think about what is the most efficient way of storing that data. Because we are talking about big data, the data is going to be huge. So what should be the file format? Should I use Avro? Should I use Parquet? Should I use some other format? I have to compare the performance of the file formats. How much of compression do those file formats offer? The comparison of how efficient are those while storing that file format, how good it is while storing, how good it is while processing. Then I have to think about archival. Whatever data is coming, how do I archive it? What data is really needed as active and what I can archive? What should be my life cycle management policy? Which means I may keep 6 months of data always in my tables or active, like a hot layer of data, and the rest of it I can just configure some rules. All of the cloud offerings provide us this life cycle management over the storage. So can I just move it to archival so that my cost is reduced and my processing is faster, because I don't store like 3 years worth of data in my table and keep scanning those, right? So these are some of the very important decisions to be taken. Coming to data processing. Now data processing is one of the critical things, because how efficient are the queries or the transformations I'm doing on data, or how am I doing the processing, will determine the entire time it takes to bring the data and give it to the consumers. So there is a need to look at what are my processing patterns. Do I need real time processing? Do I need batch processing? How what technology should I use for processing? Should I use Spark versus should I really use Spark? As in, should I use Spark and write Spark Scala program or PySpark or something, or should I use a Spark SQL, or should I really try looking at a different kind of processing? Maybe I want to use a ML algorithm. So that decision of what technology to use for processing really depends on what I'm trying to do with the data. What is my use case? So it is advisable that we build the data lake incrementally based on use cases. I don't bring all the data today into a data lake and then think of what to do with that. What I would recommend is that we decide a set of use cases that you want to serve from this data lake. Accordingly, bring the data incrementally and keep on building, evolving the data lake. And while choosing the technology for processing, it is important to know the use cases, and we can have multiple technologies doing different kinds of processing of data. So that needs to be kept in mind. Another important thing is data management. What is data management? Data management means when I'm building a data lake, it's not for a day or two. It is going to be there for years. So how do I manage it over time? And this will include things like what is my archiving strategy, because you cannot keep the entire data active. What is my backup strategy? What is my disaster recovery strategy? Which means if today I spin up a cluster, I'm using that, and suddenly something happens, what do I do? How will disaster recovery work? So is it a method where we just have an active primary and active secondary? The moment primary fails, it shifts to the secondary, or do I have a primary which is working and there is a bit of latency when primary goes down? I shift to the secondary at that time, so it's not active, it is in a passive mode, but I bring it up when the primary fails. So it is important to decide the strategy whether I will have a active disaster recovery where both primary and secondary are active, or I will have active passive disaster recovery where primary is active, only when it goes down I make the secondary active. Both have their own pros and cons. If it is a active, then we have a higher cost and we are always keeping the secondary in sync with primary. But if we have a active passive where the secondary comes up only when the primary goes down, the cost is less, but we may take some time to bring up the secondary. So it really depends on the criticality of the application, and then we decide what kind of disaster recovery do we want. And typically, when we talk about disaster recovery, we will talk about things like what is my recovery time objective, RTO, and RPO, recovery point objective, which means RTO is recovery time objective, means if it is active passive, how much time will it take to bring up the secondary? That is my recovery time objective. If it is 1 hour, 2 hour, or 24 hours, depending on the criticality of the application. So that will decide how much time can I take to bring up the secondary. The other thing is RPO, recovery point objective. It means that if the primary fails and I take 6 hours to bring up the secondary, and this I'm talking about an active passive use case where primary is active and secondary is in a passive mode, right? So if primary fails and I have to bring up the secondary, if my recovery point objective is, let's say, 6 hours, which means I will, until I bring up the secondary, I may lose some data. That is my recovery point objective. I may lose 6 hours of data and I'm okay with that, right? If the application is absolutely critical, then we have to always go with the active disaster recovery. So these are things that need to be thought beforehand because your cost will depend on that. Then comes flexibility. Now, flexibility means my data lake should not be rigid to support only one kind of use case. Though I am building it today for 2 or 3 use cases incrementally, as I said, but in future, what all may come in, and my data lake should be able to adapt to that. So I have to think holistically about what purpose am I serving. Am I doing data science use cases, machine learning, business intelligence, or what am I trying to do? So my data lake needs to be really flexible to adapt to the future needs. So best way to do it is list down all the use cases and then pick up the first top priority, prioritize them in an order and pick up the top 5 and start building. But while designing or thinking, we think holistically about all the use cases. While building, we may be really building it incrementally one by one, maybe we start with couple of use cases. So that's something that we have to work on. Now, scalability. Of course, this is the most important thing. And in the cloud, in today's world, when everybody is trying to move to cloud, this scalability has become very easy because you can scale as per the need. You don't have to really build a huge cluster thinking about 5 years down the line. You start small and you keep on increasing. And today's infrastructure, like cloud infrastructures, are so flexible, they allow you to scale, shrink, and grow as per need. So you do decide that today my need is, let's say, building a cluster of, let's say, 100 nodes. And typically nobody keeps a cluster running and static. We spin up clusters, whether we are using Databricks or something else. We spin up the clusters and we terminate those. So as per need, the clusters are brought up and terminated. So scaling is very easy, but we have to keep in mind that how much do we want to scale, and We have to predict when do we need to scale. So that needs to be considered because scalability will affect my cost as well. Now, like I said, cost. So when we do designing or we think about building a data lake, it is good practice to do costing. So all of the cloud vendors like Azure or AWS provide us the flexibility, or Google, they provide us the flexibility to get a rough idea or estimate of what should be the cost of the cluster, right? So it is better to do that kind of a ballpark estimate because it tells us that monthly this is the cost I'm going to incur, and year on year this is the cost I'm going to incur. Of course it will not be exact, it we have to assume a buffer, but it is very good exercise to do this costing, thinking about once we have finalized what use cases are we onboarding today, what is the volume of data, what technology are we using, are we spinning up cluster, terminating them, or are we keeping them cluster alive. Thinking about all those, we can do this iteration of what makes more sense from cost perspective. The moment we start building the data lake and the data lake becomes operational, the cost initially would seem low, but it keeps on increasing, and then we, by the time we realize, we have actually incurred a lot of cost. So as a best practice, the cost analysis should be done when we start building, even before we start building the data lake. Now, this is the last topic, but this is actually one of the very, very important topics. Like I said, while ingesting the data, I have to keep data quality in mind. So, data quality is not an afterthought which comes when we have processed the data and in the end I realize, oh my god, the data is not correct. So we start doing these checkpoints at every level during ingestion, like I said, the sanity checks, the basic checks, during transformation, and while we are giving the data to consumers. At every point, the data quality is done, check is done. It can be technical checks like null checks or junk character check, etc. It can be business related, where business gives us data quality rules to be applied on the data. So this is an important exercise that we need to do. Sit with business, ask them what is that you need us to apply on the data before we qualify the data to be actually accurate or consistent or of quality. Those rules are important because those checks when we do on the data, then only we can ensure that the data we are providing is of high quality. So this is one exercise that should be done in collaboration with business, and technical checks are something that we will apply at a developer's end, we can think of, right? Like what null checks, junk character checks, what are the columns that are mandatory to have, and business can give us rules like uh, what is absolutely necessary, are there any business rules that we need to apply on the data. So this is also one of the very important things. Now, I spoke about lot of criterias while building a data lake. I hope this helps all of you. So please like, share, and subscribe to the channel to get more interesting videos. Thank you. Thank you so much.